I am Dr. Sudip Das, Associate Professor, Department of Biotechnology, Haldia Institute of Technology. Today I will discuss on the gel filtration chromatography, principles and methods, and its some applications. The gel filtration chromatography is one of the separation technology, so-called base separation technology, for the separations of that is the biomolecules. It is also known as gel permeation chromatography, size exclusion chromatography, SEC, that separates molecules on the both of the size and shape. Separation by gel filtration chromatography. The gel filtration media is packed into a column to form a packed bed. The medium is porous matrix, generally spherical particles, that is stationary phase, which chosen for chemical and physical stability. Then column packing, sample loading, equilibration, that is done with isocratic manner. Isocratic manner means that is with the same mobile phase that will not be changed during that is the packing or loading the sample or equilibration, etc. Packed bed is equilibrated with buffer which fills the pores of the matrix and the space in between the particles. Samples should be equilibrated with the loading buffer. Now, what is the stationary phase and what is the mobile phase that has been used in every gel filtration chromatography? The liquid inside the pores is sometimes referred to as the stationary phase, and this liquid is in equilibrium with the liquid inside and outside the particles, referred to as the mobile phase. Samples are eluted isocratically, that is, there is no need to change or no need to use different buffers during the separation. In gel filtration chromatography, that is the theory behind it, that is the column matrix we used. The column may be made up of glass or may be made up of that is polypropylene materials or that is the any metal materials that is actually hollow that can contains that is the or hold that is the porous beads or gel filtration media. The large molecules that are excluded from the pores and travel through the column fastest, and the small molecules are included can diffuse into the pores and elute later. In gel filtration chromatography, there is a mixture of large and small proteins that are loaded onto the column, that is upper layer, and then these we use that is the mobile phase that may be used, that is you can say that is add buffer to wash the proteins through the columns. In case of the protein separations based on their the size, that is polymer gel beads say is some molecules that are trapped and they're traversing through the gel filtration media that is going flowing on, and some molecules that are excluded, and then we collect the fractions. Column parameters of the gel filtration chromatography. V0 is equal to the void volume that generally excluded to the gel filtration media. That means excluding the gel filtration media. Vt or Vc is equals to the total volume, the physical volume. Vs or Vi is equal to the volume of the solvent held in the pores. This is normally approximated to Vt minus V0 is equals to volume of the beads. V0 is the elution volume of the large or total excluded molecules such as Bludexton that we used for the determination of the void volume of the chromatography media, generally the chromatography column. Most of the time that is the gel filtration chromatography, where that is the V0 is very important parameter. Vt is the physical volume of the column. This slide shows on that is what is the void volume V0 and the total column volume Vt or Vc, and then Vt minus V0, and then the next picture that is the gel filtration chromatography elution profile. Okay, that is V0, that is where that is high molecular weight. Okay, that is species that will be excluded completely through the column from the column and eluted first. Then VE, that is the uh, which is included within the column within the internal. Okay, that is the phase or stationary phase, and they will be eluted in different time. Smaller the particles, smaller the proteins, in case of that is the proteins, that will be slower, their elution will be slower. And then low molecular weight proteins, that will take lower time, that is the higher time. And the lowest molecular weight protein, that will take, that is the highest time to elute from the column. And the in the intermediate molecular weight molecules, okay, that is between the high and the lower weight molecular weight proteins, according to their size, they will be eluted from the column. And the interacting medium molecules, which is actually adsorbs non-specifically with the column, they will not be eluted. This figure shows, that is the graphical representations of the chromatography. Okay, that is the chromatogram of the gel filtration chromatography. First, the equilibration step, that is equilibration, that is actually done by only, that is the mobile phase in isocratic manner. Then that is the sample injection. Then that is the V0, which represents, that is the totally excluded molecules that will be eluted out first from the gel filtration chromatography media. Then high molecular weight proteins or the species, okay, that is they will be eluted out. Okay, then and then intermediate molecular weight proteins, and then they will be eluted out according to their molecular weight. And the low molecular weight proteins, they will be eluted out, okay, that is in a very longer time. And then the void volume V0 here, and the total column volume Vt, that is all the molecules which are included to the columns, they will be excluded within the one column volume of the gel filtration media. This is the example of size exclusion chromatography. Here the sample mixed with, that is the mixture of proteins. Here 60 kilodalton, that is the highest molecular weight protein, low pi. And then 20 kDa protein, that is of low pi, with that pi is 7. And the 20 kDa protein another, that is the high pi, that is the pi is 8. And the smallest protein, that is the 5 kilodalton. Then you so see, that is how that is the proteins that are going to be, okay, chromatographed through the gel filtration chromatography. The lowest molecular weight protein, that will be included, that will be trapped much more by the gel filtration media. And you see, that is the intermediate molecular weights, that will not be trapped much more, as that is the lowest molecular weight proteins, that is 5 kilodalton. And that will not separate the 20 kilodalton of different proteins. Maybe one of the pi is 7 and another is the pi is 8. And then 60 kilodalton protein, that will be eluted out first. And then the mixture of the 20 kilodalton protein, both of, that is one of them is the lower pi 7 and higher pi 8. And the last, that is that will take longer time, that is the for the elution of, that is the from the media, the gel filtration column, that is 5 kilodalton, that has the high pi 8. And this is actually the separation technology of the gel filtration chromatography, media, and you see that is how that is the gel filtration uh, separates, that is the different molecular weights mixture of 60 kilodalton and 220 kilodalton and the another 5 kilodalton. We process the elution of a sample is best characterized by the distribution coefficient Kd, or this is called the KAV. Okay, that derived as follows: the volume of the mobile phase is equal to the void volume, that is the V0, the elution volume of the molecules that remain in the buffer because they are larger than the largest pores in the matrix and pass straight through the packed bed and are excluded from the column. In a well-packed column, the void volume is approximately 30% of the total column volume. This slide represents the Kd fraction of the stationary phase that is available for diffusion, means the separation actually of a given molecular species, mixture of species you can say, and are included in the column, that means trapped in different time and different extent, and they will be eluted out from the column in different time. The smallest that will take, that is the longer time, and the larger that will take, that is the that is lower time to exclude from the column, to elute from the column. The stationary phase, that is the Vs or Vg, or that you can say the Vi, that can be substituted by the term Vt minus V0 in order to obtain that is the Kd. So Kd or Kv is equals to V minus V0 divided by Vt minus V0, or is equals to V minus V0 divided by Vi. For an ideal gel filtration chromatography, Kd is lie between 0 and 1. That is, maximum value will be less than 1 and the minimum value will be 0. As per the equation, the possibility to occur of a mixture of solutes of different molecular size and weight during GFC or gel filtration chromatography, or gel permeation chromatography, or cyclisation chromatography. Case 1, that is for large molecules which are completely excluded from the gel, Kd is equals to 0, and then that is the V will be V0. That means their elution volume will be, that is the V0. For molecules of very small size which have completely accessible to the gel pores, that means that will access all the gel pores, all the gel beads, all the internal, that is the phase of the gel filtration media, then Kd will be 1 ideally, and then V is equals to V0 plus Vi. So for molecules of intermediate size, Kd will vary between 0 and 1. If, however, Kd is greater than 1, then adsorption of the compound, that means non-specific adsorption of the compound on the gel has occurred, and such a situation that should be avoided. Now the determination of V0, the void volume is volume of the liquid required to elute the molecules that are completely excluded from the gel. This is determined by the chromatography by a high molecular weight substance such as blue dextran, whose molecular weight is 2000 kilodalton, which cannot elute the gel, which cannot enter the gel pores. The solvent volume which leaves the column between the start and appearance of this substance in the effluent corresponds exactly to the volume of the liquid media, that is the gel particles, that is the void volume. Okay, so when we measure the void volume, we will measure the in which time, that is the elution time, and then which volume that will take, that is the to elute, that is the high molecular weight blue dextran, that is from the gel filtration column. Selectivity curve, that is selectivity curves are usually quite linear over the range, that is KAV is equals to 0.1 to KAV or KD is equals to 0.7, and it is this part of the curve that is to use to determine the fractionation range of the gel filtration media, that is actually showing in the that is the slide. In x-axis we represent here, that is the KAV or KD, and the y-axis, that is the fractionation range in the unit of log of molecular weight. You see, that is the spherical rate is actually represented here, that is the included mass or the species of the gel filtration media, and the dotted line, that will be actually the exclusion limit or the molecules that are excluded from the column. Selectivity of the equation, the middle range of the selectivity curve may be approximated to a linear relationship given by the equation, that is Kd or Kav is equals to A minus B of log of molecular weight, where B the slope of the selectivity curve depends on the width of the pore size distribution of the column material, and A the value of the intercept is a function of the mean pore size. And this case, the practical working range of the gel to be 0.1 to 0.7. That means the Kd value will lie between, that is the 0.1 to 0.7. That is greater than 0.1 or the less than, that is the 0.7. This is the maximum reasonable area where the portions of the selectivity curve, where that is the different molecules which is actually included by the column, that will be separated in different time by different elevation volume. Selectivity may also be given in terms of relative retention as an equation, that is alpha is equals to VE2 divided by VE1. Application of gel filtration chromatography. First is the fractionations. Fractionations means, that is, we can get the fractions of the different molecular weights of the species. Separations of monomers from dimers and higher aggregates, that is generally from after polymerizations of a polymer, that is a species. Estimation of, that is the molecular weight of the different species. In case of the protein, that is very specific. Determinations of molecular weight of distributions of the polymers, and then desalting. And also we can use the gel filtration media for removing of, that is the detergent. Applications, that is, since large molecules elute earlier than small ones, proteins and peptides will elute in the buffer used to equilibrate the gel filtration column regardless of the origins of the sample of the solvent. GFC can be used for desalting, buffer exchange, or that is the equilibrations of a particular molecules or the species, low molecular weight contaminants. However, its unique selectivity allows dimers and larger polymeric forms of the target molecules to be separated from monomers, and denatured forms may be separated from native ones. Gel filtration is commonly used in two different modes, that is high resolution mode to separate large molecules like proteins, peptides, oligonucleotides, polysaccharides, etc. That is figure 1 and 2 represents, that is the main points, that high resolution mode to separate, that is the large molecules. Group separation mode, that represents, that is in the figure in the slide, to separate large molecules that is greater than 5000 Dalton as a group from small molecules like salts and buffer ions. That is, here you see, that is one is the albumin and another is the NaCl. That means the albumin protein that is actually dissolved in the NaCl. How that is albumin that can be desalted from, that is the NaCl. Group separation modes accepts much larger sample volume than higher resolution on mode and can be performed at considerably higher flow rates. Samples small Gravity-driven columns are normally used to desalt samples with volumes that is generally 1 ml. So-called spin column used for post-PCR cleanups for cleanup of labeling oligos and examples on chromatography driven by centrifugation. The great advantage with centrifugation driven column is that a very large number of samples can be dealt with the parallel. Performing a molecular weight determination, we first use that is the cell packed column, prepare as a fresh filtered solution of blue dextran that is 2000 kilodalton and the concentration is 1 mg per ml in the running buffer. Apply blue dextran to the column using volume that is less than 2% of the total column volume, that is Vt, to determine the fat volume V0 and check the column packing. Dissolve the selected calibration protein in the running buffer at concentration recommended by the manufacturer. Allow few minutes for dissolution, stirring gently. Do not heat a mix vigorously. If necessary, filter calibration solution. Then that is apply the calibration solution to the column in a volume less than 2% of the total column volume, that is Vt. Determine the elution volume Ve for the stationary standard by measuring the volume of the eluent from the point of the application to the center of the elution peak. Calculate the KAV or KD values for the standards and prepare a calibration curve KD or KAV versus the logarithm of their molecular weight as follows. KD or KV is equals to V minus V0 divided by Vt minus V0, where V is the elution volume of the protein, V0 is the column void volume or elution volume of the blue dextran 2000, Vt is equal to total bed volume. On semi-logarithmic graph paper, plot the KV or KD value for each protein standards on the line scale against the corresponding molecular weight on the logarithmic scale. Draw the straight line which best fits the points on the graph. Alternatively, use a statistics package to calculate the regression line. Apply the sample in a volume less than 2% of the total column volume Vt and determine the elution volume Ve of the molecule of interest. Calculate the corresponding KAV or KD value for the component of interest and determine its molecular weight from the calibration curve. Now it shows the determination of molecular weight. Calibrate column with known standards. Plot KAV or KD against that is the molecular weight of that is the protein. Shows on that is the difference size exclusion chromatography or gel permission chromatography, that is media. One is the Cephadex, PDX, Cephacryl, T-Sacryl plus and their fractionation range. That is the gel materials, that is the stationary phase. The polymer which is actually prepared for that is the Cephadex or PDX or Cephacryl or T-Sacryl plus, and the cross-linking polymer, cross-linking, okay, that is monomer and their fractionation range. General principle for column chromatography, that is the gel filtration column chromatography. First, the gel selection, that is very important. Make target protein elute or column earlier. Bead size, finer bead has better resolution, slower flow rates. Column size, use larger column size but consider practical need. Column shape, that is the slim column for gel filtration, fat column for others. Pack the gel tightly for better resolution. Flow rate, fast flow reduces resolution. Slow flow rate is actually considered for the gel filtration chromatography. And sample volume, that is less than 1% to 2% of the total gel volume of the sample of the gel filtration media. Here is our sample mix of proteins. Our goal is to purify the protein. The 60 kilodalton, one protein and two proteins, two different proteins actually. One is of 20 kilodalton Another is also 20 kilodalton, another 5 kilodalton. Gel filtration chromatography separates proteins according to the basis of size and shape. So we'll start with that is the 4 proteins. We'll want to purify that is the yellow one. The matrix of size exclusion chromatography column is porous beads. That size actually shows. The matrix of gel filtration column beads with pores. The larger green proteins can't fit it pores, so flows faster. The red, yellow, medium sized proteins get trapped in the pores. The black small proteins stay trapped in pores of longer. The black can penetrate all pores and the space between beads. The yellow and red can permeate the space between beads and larger pores. The green will be restricted to the space between beads. So in this lecture, what is the gel principle and practices of gel filtration chromatography? This is actually elaborated very briefly, and their short applications. There are the huge applications is actually generally in the biotechnology laboratory, that is the gel filtration chromatography or gel permeation chromatography or size exclusion chromatography. This is the end of my lecture. Thank you very much.